In this tutorial, we're going to compare dose measurements on film with a patient-specific treatment plan. I'm going to assume you've completed film calibration and generated a dose map, and you're going to continue to use the EBT3 Rapid Arc example included in the Film QA Pro installation package. The route is shown at the bottom of the screen. The next step is to highlight the fiducial marks delineating the axes of the treatment system and ISO center. Notice I've adjusted the image window size to make the dose film easier to see. Look at the film image and you'll see small black marks close to the center of each edge. These correspond to the position of the crosshairs when the film was exposed. While the recognition of these marks could be automated, human pattern recognition is superior when films have other identification marks as well as the fiducials. So it's quicker and more reliable for you to pick out the fiducial marks and highlight them before the software does the fitting. Click on the Fiducial Management tool. It's the second icon from the top of the toolbar, and use the general fiducial point. Since the fiducial marks are near the centers of the sides of the films, the software senses whether a particular point is to be fitted in a vertical or horizontal direction, but you could force a specific selection if needed. Now point and click on each mark in turn, and the highlight marks appear. Fiducial fitting is done using the center of the highlight marks, not the marks scribed on the film. For precise positioning, click on a highlight mark, hold down the Control key, and use the keyboard arrows to move the mark. The next step is to add a new object to the case tree. So click Add New Case Object at the bottom of the case tree. Expand the drop-down menu and select Dose to Plan Comparison. After the Dose to Plan Comparison object appears in the case tree, click the plus sign to expand the object. Notice that a thumbnail image of the dose map has been automatically added on the second line of the object. If you were working on a case with multiple dose maps, you would have to pay attention to dependencies. The first dose map in the case tree is added automatically. So if you want to work with a different dose map, you need to click on the second line from the bottom, Dependents Dose Map Single Scan, and select the correct dose map from the pull-out list. Click the thumbnail to show the dose map in the image window, and then point and click the top line in the case object. Since this plan exists as a TIFF image, select Open Image Treatment Plan from File, and navigate to the example EBT3 Rapid Arc folder to open the file ccw_cw_plan.tiff. In other cases, you can open a file with a format specific to one of several treatment planning systems by selecting Open Treatment Plan. Or you could choose to open a treatment plan from a DICOM file. A thumbnail of the plan appears on the first line of the Dose to Plan Comparison object. Toggle between the plan image and the dose map image. You'll see they have similar orientations, so you won't need to flip or rotate one relative to the other. If the orientations were different, you could make the correction here by using the Flip and Rotate tool to change an image orientation, or you could wait and make the changes in the Image Comparer. Now click on Tool Image Comparer to activate the Comparer tool. The image window now displays the dose map overlaid on the treatment plan, but obviously misregistered along the X and Y axes. If the misregistration also required the dose map to be flipped or rotated relative to the plan, this is where you'd go to the toolbar and use the Flip and Rotate tool. However, in this case, only translations and maybe a small rotation are needed. Activate the Fiducial Fit tool. It's second from bottom on the toolbar, and select Fit Fiducials horizontally, vertically, and rotationally to align the images. At this stage, the results of the gamma analysis shows more than 99% of pixels passing with the default test criteria of 3% and 3 millimeters. However, at 3% and 3 millimeters, the test is usually insensitive for most IMRT and VMAT plans, since shifts of 2 millimeters or so in the alignment of measurements to plan usually has little effect on the passing rate. A better way is to sharpen the comparison by using a test of 2% and 2 millimeters, and this has been facilitated because we use the one-scan protocols discussed in the calibration and dose map tutorials. Enter the new test criteria in the tolerance and distance cells at the bottom of the analysis window. Type in the new value and press enter to make the change. With the test at 2% and 2 millimeters, more than 90% of pixels are passing. The result could be fine-tuned in a number of ways. Firstly, by adjusting the region of interest for the analysis. Activate the selection frame tool and change the size, position, or shape of the frame as desired. In this case, I have made the area slightly narrower to avoid the fiducial marks and less tall to correspond to the plan exposure. In doing this, the passing rate has fallen slightly. Narrowing the region of interest in this way has the effect of excluding low dose points from the analysis. An equivalent effect could be obtained by entering a non-zero value in the minimum threshold cell at the bottom of the analysis window. Excluding low dose values prevents the analysis from being biased by areas of film that were exposed primarily with scattered radiation. This particular example, we're using an ROI and a minimum threshold of 10%. That is, dose points with values less than 10% of the maximum are excluded from the analysis, and the passing rate is now about 89%. A significant source of misfit between measurements and plan can result from errors in marking the fiducial points. Differences of 1 to 2 millimeters are not unlikely. To investigate this, I'll demonstrate the manual adjustments in the alignment of images. One way to visualize small misalignments is to use the ISOLINES tab in the analysis window and display an isoline plot of dose distribution. If you want to edit the dose levels of the contour lines or change the display colors, then click on the chart legend and select Edit Color Levels and Palette. That accesses a panel where the changes can be made, and color palettes can be saved and recalled. In the current example, the ISOLINES plot shows the measurements, represented by thin lines, are shifted a small distance to the left of the plan, represented by the thick lines. Now activate the Image Movements tool by clicking the icon on the toolbar. Manual movement of the dose map image is made using the large round button for rotational movements and the square button for translations. The speed of movement is set from the Image Movement Speed icon on the toolbar. Click to toggle between coarse and fine motion and refine the speed by using a setting from the drop-down list. Rotations are made relative to a user-defined rotation pole. Right-click the image movement icon and select Show Rotation Pole, and then Move Pole to Center Cross. This usually corresponds to the ISO center and is often the best selection, but other options are open. To move the measurement image, you can turn the round button directly or use the arrows in the square button to make XY movements. Alternatively, click a button and then use the mouse wheel or keyboard arrows to make changes. Experiment with the various movement and movement speed settings and use the ISOLINE contour fit and gamma results as guides to achieve the optimum alignment of the measurement and plan images. With gamma test criteria of 2% and 2 millimeters, the analysis is very sensitive to small changes in position and rotation, and with a few clicks of the alignment buttons, you'll get the passing rate up to 96%. Notice that the translational and rotational shifts are recorded in the cells alongside the movement buttons. The default unit for translational motion is in pixels, but this can be changed to length in millimeters. Just point at a value, right-click and select. In the demonstration example, a rotation of about half a degree and a translation of 0.9 millimeters in X and 0.2 millimeters in Y has changed the passing rate by about 7%. Do a little bit investigation yourself, and you'll find that with the 3% and 3 millimeter test, the passing rate changes by only about 1%, even for a 2 millimeter relative shift. Other features can be accessed using the tabs in the analysis window to display various charts and tables with analysis data, and any of these data can be added to the case report. Many of the display parameters, for example, axis ranges, line widths, display colors, etc., are automated or set by default. But if you right-click in the display or near the axis or on a chart legend, the settings can all be customized. If you want the customized display to be added to a report, be sure to update the record by clicking the icon at the far right under the display so the custom settings are used in the report. The Profile tab displays profiles across a user-defined path. Click the profile icon in the toolbar to select the profile type, for instance, horizontal, vertical, diagonal, circular, etc., and also the width of the profile path. Profile path can be rotated or translated by grabbing and dragging with the cursor. Alternatively, you can get more precise control of the profile path by clicking the path editing icon underneath the chart to display and then use all the profile path editing tools. Right-click in the profile display or near the axes to change various attributes including dose, length units, axis ranges, line style and width, and so on. Right-click also and choose Display Mode to show a table of values in addition to the chart, and also to copy the tabular or chart data to another application. Use the ISO Map tab to show a map of gamma values for a selected color channel. Click on the chart legend to edit the ranges and display colors. Use the Map tab to display a map showing for each color channel the location of pixels failing the gamma test criteria. And use the Comparison Map Selector icon below the chart in the analysis window to select between differential delta, gamma, and distance to agreements maps. For any of the quantitative evaluation functions, use the icons under the % tolerance test criterion cell to select whether the tolerance is relative to maximum dose by default, relative to a user-defined dose, or relative to the local value in the plan. Use the icon under the distance test cell to select the options for that criterion. Finally, under the Report tab, make a custom selection of the charts you'd like to see in a report. By default, all the quantitative analysis results, gamma, distance to agreement, and differential delta, are included. Select the layout and number of charts per page, and specify for which color channels are charts to be included. A document template can be saved for future use or loaded for current use. If you have customized any of the charts for the report, you should have updated to specify the customized settings that to be used. But in case you did not, click the icon at the far right under the section where the report pages are shown to do so now. And if you've made a change to any chart after specifying the contents and layout of the report, click the big red star to update the contents. That concludes this tutorial on dose-to-plan comparison. Now you have the basics. But as with other applications, there's a lot more capability to discover when you go exploring. Other video tutorials in this series give an overview of Film QA Pro and address scanning, calibration, dose map calibration, as well as various machine QA tasks.